Then reduced row echelon method, we're going to use row transformations to get the augmented matrix into reduced row echelon form, where we not only have zeros in the bottom triangle, but also in the top triangle. And then this will directly give us the answers. This will mean that x is the first number, y is the second number, and z is the third number. If you get a whole row of zeros with only a number in the augmented portion, meaning there's no x's, no y's, and no z's which are equal to that number, that's inconsistent. If you get two identical rows, then there's an infinite number of solutions and their form depends on what you get. On the TI graphic calculator, this is reduced row echelon form, which I think is option B, with the one right underneath here. So this one was option A, at least on my calculator. Some of the older ones that might be different, but this was option B for at least those that have the TA84 like I do. So now let's solve this one again. We're going to do some of them by hand, even when they're 3 by 3. So again, first we transform this system into augmented matrix by pulling off the coefficients and then put our dividing line and then the constants. And now again, the way you normally work is you pick the first element and you try to make the ones beneath it zeros. Then you move on to the next one and you try to make the ones above and below it zeros. And finally you move to the last one and try to make those above it zero. And at the same time you're also going to work on making these ones if they're not. So I'm going to try to make this element a 0. So I'm going to take, I need these two to match. I'm going to take twice this one and subtract this one, will end up giving me a 0. And then I'm going to put it back into this row. So I'm going to take 2 times 1 minus 2 is 0. 2 times 2 minus a minus 1 is 5. 2 times minus 1 minus 3 is a minus 5. 2 times 5 is 0 or 2 times 5 is 10 minus 0 gives me 10. And I put that into the second row. And now I could change this into a 1 right away. I've left it for the end here, so I'll just follow that. I'm now going to make the next one. As I said, I could have divided all these by 2, but because I'm going to do other things to these, I decided to leave that till the end. But now I'm going to make things easier because I don't want to have to multiply this by 2 and this by 5. I'm just going to make everything here and this one a 1. So I'm going to divide everything here by 5, giving me a 0, 1, minus 1, 2. Then I'm going to compare these, and again, I'm trying to get rid of this one above, and I'm trying to get rid of this one below. Now I could do both of these at the same time, but in the beginning you might want to do them in 2 separate steps. So I'm going to keep the row with the 1. I'm just going to write that one down. So I simply wrote that row, and here, because I'm not doing anything to this one, I wrote it as well, but if I wish to do it at the same time, I would leave it as blank as well. And then I'm going to well, how can I go from these 2 rows and get a 0 here? Well, if I just add these 2 rows and then put them back into the first row, I will end up with a 0 in that spot. So 0 plus 2 is 2, 1 plus minus 1 is 0, minus 1 plus 3 is 2, 2 plus 0 is 2, so I put that into row 1, and I kept that. As I said, I could have left this empty and done this at the same time, but I chose to rewrite that. And now I'm going to compare, okay, I have in this matrix, I have a 1 and a 2, how can I get rid of that? Well, if I double this one and subtract this one, and then put it in the third row, I would end up with a 0 there. So if I take 2 times 1 and subtract 2, I get 0. Well, 2 times 0 minus 0 is 0. 2 times 1 minus 2 gives me 0. 2 times minus 1 is a minus 3. 2 times 2 minus 1 is 3, and again I put that in that row. Then I want to go to the next diagonal element, and again I'm going to make that 1, so I'm going to divide everything by minus 3, giving me 1 and minus 1. And I also decided to do the first row now and divide everything by 2. Again, I could have done that earlier. So now I have 1, 0, 1, 1. I've divided everything there by 2. I'm dividing everything here by 3, gives me this, and the second row I left unchanged. Now I want to get rid of both of these because I've got the zeros below. I now need to make these zeros here. So if I take this row and well, it could be either way. I'm going to take this row and subtract this row, and put that into 1. And the reason I would do it in that order is I want to keep that on a 1. So I'm going to take row 1 and subtract row 3. And for then the next one, again, I could do both of these at one time. I could take these 2 rows and add them and put them into row 2. I've shown it in 2 separate steps. So I kept both of the second and third and wrote it. I'm only changing the first row. I'm going to take 1 minus 3. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus a minus 1 is 2. That took care of that one. Then again, now I'm going to keep the first 2 rows and just write them. I'm only dealing with rows 2 and 3. I'm just going to add them together, and that will go into row 2. 0 is 0 is 0. 1 plus 0 is 1. Minus 1 plus 1 is 0. And 2 plus minus 1 is 1. That now gives me the zeros above and the zeros below. And finally, I know that that means x equals 2, y is equal to 1, and z is equal to minus 1. And again, you do it on your calculator in the same way that you did it before. You just now, instead of using REF, you use reduced REF.